what's driving that valuation of Databricks?
At a certain point, trying to process all of this data is a bigger business than the business you're currently in.
Who is this for? Like, what is the plan? Because if your plan is to do nothing, I mean, just keep doing that, right? Like, save yourself some money, save yourself a ton of time. Like, there's all these companies spending tens, if not hundreds of millions of dollars, probably billions in some cases, trying to become data driven, and not getting anywhere.
Hi, everyone. Welcome to Code and Connor podcast. My name is Connor Deek, CEO of CodeStrap, and I'm joined, as always, with the original CodeStrap himself and CTO, Dorian Smiley. We're going to be bringing you guys the latest and greatest around Palantir, the tech, the company, the community. We'll also be discussing insights on other companies, things happening in the world of AI, of data, of consulting, of investing, and any meaningful topic that requires attention. The focus of today's episode is the importance of large-scale data engineering and the difficulties in doing it correctly. We're joined today by Ben Rogojan, better known as the Seattle Data Guy. With 7 million views and 115,000 subscribers on YouTube, Ben is the go-to expert on all things data engineering and science. Ben has spent his career focused on helping companies develop end-to-end data solutions that are both simple and maintainable. Certainly no easy feat. Ben, welcome to Code and Connor.
Hey there, thank you for having me.
Welcome, dude.
So, first topic on the docket is the struggles around data engineering. What are you guys seeing? What do you deal with? What do most people seem to think a platform might be able to solve, but skip over? I'll kick it to you guys to talk.
Yeah, Ben, I always appreciate your commentary around this topic. I a lot of the, especially your LinkedIn posts and stuff, just around the sort of issues around everyone's data is garbage. A lot of the way companies even think about how they build these engineering processes around the data are just complete garbage. And that you're never going to get to like I've seen this myself where it's like at one point at Brainly, I think we had 20 data analysts like analyzing data and we weren't getting any answers on the other, like not usable in a real chat. And that was, there was some good work being done, but in a large part, just it feels like a lot of times you push more resources and people at these problems, you're not getting any output out the other end. So as maybe you could talk about your experiences there and the challenges that companies have around leveraging data and data engineering.
Yeah, no, I think there's a lot of companies out there that resonates a bit. Recently, even this year, I was working with a few companies where it's like they clearly were spending a lot of money on data teams, and like it's funny that then you go and talk to their CEO, and the CEO is like, I have no insights, like I don't know what's going on, I don't know my numbers, and like how do you have like hundreds of dashboards? You're using all the tools. Like in one case, it's like you're using Snowflake and Databricks. You like have all of this, and you're still like uncertain. You're still like, I don't know, like what number to use for active users. And it's the same thing I've probably been saying. It kind of feels repetitive sometimes. But I'm like, oh, this is like 4 or 5 years of content creation, of video content creation, even more of written, and still kind of saying the same things. Even in the world of AI, it's like, it's funny. I just wrote an article, I think last week, where I was talking about like things that have like 5 things that haven't changed in the last decade of data engineering. And like, look, we're doing a lot of the same things. Things are more complex in ways where people want more, but in terms of like the actual core problems, it's like we're still just trying to get data from source systems into some whatever it is, Palantir, Snowflake, Databricks, whatever, to try to do your analytics, and then trying to get those questions answered. And some people are winning, some people are not. And it's still a lot of the same stuff.
This problem around like everyone's got a different definition of churn and monthly active users and whatever. It's like CEO's got one number, marketing's got another, finance is seeing some other metric. Like I've experienced this firsthand too, where like finance, especially finance, will use different numbers than marketing or other teams. What do you think the root cause of that is? Is it like a structural problem where there's just a bunch of independent teams and they're all under different mandates to report differently on these things? Or like, is it literally bad engineering that goes on and that's why you get a different number? Like, what do you think the root cause of that is?
Yeah. I mean, I think the problem is there's probably multiple root causes depending on the company you work at. I've seen them all, right? One recent problem, for example, I was working out with a company. It was like trying to define something as simple as like how many months of subscription someone had like been for a product. And it's like, well, what if someone canceled their subscription halfway through a month? Are we counting that as a full month? Or are we counting that as half a month? Well, for one team, they're like, well, we're going to count it as a full month. For another team, we're going to count it as half a month. for one reason or another, right? Especially finance, they've got their very particular terms, especially connected to accounting. And yeah, that's always hard to win. And then I do think on the engineering side, honestly, I've had a lot of conversations with data leaders, and sometimes it's just like basic disciplines that are not exciting and is hard to do right all the time, right? Like if you don't have someone constantly demanding that excellence, it's just hard to do. So you're like, well, I got to get this done. I'll fix this problem later, and so you just keep pushing forward. Whatever you're writing a query, you put in some patch for now, and you're like, this is fine. And then it comes and bites you or bites some future engineer who had no idea that this was happening. And so I think, that also happens where it's like sometimes we know the right thing, but because we have to move fast, we feel like, well, we will fix it later. And I think that happens a lot too. So that's why it's like root cause. I think there's multiple, and every team you go into, it's something different. I did a recent kind of overview of a company, and I was like, oh, well, one big problem is that your data team doesn't really have a vision. And because of that, they just get pulled every which direction. And because of that, they're doing things that they're not necessarily good at, and they're just building everything you ask, and they're not pushing back, and all of that just kind of comes down to this lack of building the right thing, and then you never get right answers, et cetera, et cetera. It's weird where problems can arise.
Right. Right. That velocity thing. So like when you move fast, Connor, I've sort of turned you into the person who now is like demanding unit tests and lineage and, monitoring views on every every pipeline, every data set. Like Connor has a little bit of experience here. Like maybe Connor talk about how we're trying to force teams to move the needle on quality, because it does hinder your ability to change things. Like if you don't have good quality controls in place, if you change something, you don't know what the impact downstream is going to be. Connor, maybe like talk a little bit about how you're pushing teams on the quality.
Yeah, everyone always thinks that getting to an answer faster is the right answer or the right pattern to follow. But inevitably, the data that work that first run through the data pipeline is going to fail on the second or third or fifth try, particularly when you start to scale up the size of the data. So it's kind of like the paradigm of slow down to move fast. And if you're not putting unit tests, I mean, basic data quality checks against it, like a schema check, then you're inevitably going to experience a lot of churn and then have to rework those things. And going through your work after you haven't documented, after you haven't put any type of tests, if you've been away from that data pipeline for a few days or weeks or an even longer period of time, is going to cause you to spend a ton more time had you just put a bit of upfront legwork into putting those unit tests, those health checks, data validations, basic documentation. Like, I don't know why it is so hard to get someone who's qualified using SQL or low code tools or Python to add a sentence or two sentences in a block of code, but it is. So most teams don't follow that pattern. So if you can get people to understand why they should do those things, and after they've made the mistake of not putting those in place, having them understand what it caused for the whole team, particularly downstream, you can get people to start to follow those patterns so that you don't continuously put out really non-production pipelines.
No one wants to do this, dude. No one wants to write tests. Like I don't like to write tests. No one wants to do it. No one wants to sit there and write the assertions. Like maybe there is like everyone right now is obsessed with like how do I reverse and how do I create the ontology or target, data sets from the source data? Like how do I automate that away? And really it should be like, how do you just make sure they're test generated and like, actual quality assertions generated? Just focus on that problem. And maybe it's like a higher value, like ad in the end of the day. Cause like, I always feel like when I work in a large mature code base, we spend a lot more time fixing bugs and like general refactoring than we do adding new features. It's like kind of like that law of software evolution where like the more code you add, the harder it becomes to add more code. And like at a certain point, the system just feel like it's constantly pushing back against you. Like every time you want to make a minor change,
Yeah.
But I'd be interested to get your take on like, what do you think is the most valuable thing that, as far as a quality control, that companies could implement to try and make sure their sources of truth are actually sources of truth and not like sources of fiction? For me, I'm a huge fan of unit tests because they run before the pipelines run, and like it actually checks the code that's doing the transform. It's hard to know all the edge cases, obviously, so that's probably the challenge in building those. But for me, it's a faster feedback loop. Like I don't have to wait for this pipeline to go run to know like did the quality checks fail or whatever. It runs 2 hours and halfway through, I get this error. It's like I want the immediate feedback. But like, what's your thought on like where are you investing in trying to improve quality? And when you start projects, like what are your views on this, because it can be, perfect quality could be its own endeavor. I mean, you might be doing that for money. That just slows the project down too. There has to be a balance between these things. What are your thoughts on that?
Yeah, I think in general you try to focus like your time in the whatever the columns, the entities that are going to be the most valuable, right? Like you're not gonna put a million checks on something that no one's using. That's never great. You also have to be wary of the whole. I was just talking to someone about this, like alert fatigue. A lot of people have that. Like even when I was at Facebook, it's like, I'm like, oh yeah, I'll just put all these checks on things. Then after a while, you're like, okay, this keeps failing. I know where the source issue is. I've talked to the individual. They're not fixing it. I can't do anything to make it better. So either I have to put a patch or I have to ignore this error check that keeps flagging me every day. So there's that aspect. I think again, if something is important enough, you can get people behind it, but that's a whole other aspect of data engineering, and I think a lot of us don't like have to go play political games in that sense. I do like one unit test, especially like on columns, just to make sure, hey, like, does this column make sense? Because the big thing about data pipelines, right, is like they can operate functionally correct forever, right? Like, hey, it built it. It's running functionally the way it should, but internally that data can be failing soft or quietly forever, right? It's like, oh, maybe this data is somehow getting truncated or whatever the issue might be. And so like having those unit tests, I think, are always good, just to have like some quick fix. The way I remember the first company I worked at, or like where we really had a lot more discipline, was that first layer we'd have a certain types of checks where they'd just be really kind of dumb checks, like, is this date, is this int and int, just making sure, because especially because we're getting external files sent to us where it's like someone outside of this company could be screwing us over and they might not know it, right? They might send us a different file, so like let's just make sure before we go spend, like you said, those 8 hours or 2 hours processing this massive file, that it's the right file. And so then you spend that first time just to be like, okay, is it the right file? Is it the right columns? Is it the right whatever? And then from there, you start adding in more layers. Like, okay, we've done a transform on this. Let's make sure on the other side that, like, an easy thing is like, okay, if we had X number of columns on one side, we have, or X number of rows on one side, we still have the same number of rows. Or if we remove some, we know how many we removed, and we can kind of prove that on both sides. Another way we've done it is we've had like two analysts or two engineers kind of build the same query without like be like, hey, here's the goal of the query, write it, you know, and you'll always get different answers. Like you'll write it. Someone rounded something differently. Someone rounded earlier. Someone rounded later, and you get different answers. Then it's like, okay, now you have to ask which one's right. Like, which one do you think is more right? Not everyone has that time or resources, but if you can, that's definitely something I've been found very helpful.
I see these companies, because a lot of what you're talking about, that's the actual discipline of good data engineering, and it requires a lot of investment. Like, I don't think companies realize exactly how much work goes into having high quality data, yet they spit out these dashboards that do none of these things. And then they pretend that they're going to make all these data driven decisions that move the needle for the company, yet not going and doing all this foundational work and understanding the full discipline they're trying to implement. And then I always think, like, well, why are you so obsessed with data? Like, on some level, you're making a trade-off here between like running your business with data being one signal with a lot of others, and maybe you're better off building faster feedback loops at the consumer level or some other place where you can get better feedback. Because like, to get feedback from data is hard, and like the things you're bringing up is like, and then there's a bunch of complexity around it that they add. Like, they'll create a CDO, and then the CDO has 80 copies of the same data distributed out to these people, and because they never figured out a way to like fully manage exports from, say, Snowflake or some other thing. So now there's 15 different tables that are essentially the same data, but like they're slightly different, and people are getting like different answers because of that. So like, they're stacking complexity sort of at the source of where the intake is, which has massive impacts when the engineers go to build. There's a massive cost trade-off there. Then they don't make the investments in the actual engineering discipline. So like, the data that comes out the other end, super questionable. And then like, at the end of the day too, like, is there just a better way that you should maybe be trying to like answer these questions rather than looking at data all day? Maybe there's like some other discipline, so like, I don't know. What are your thoughts? Like, do you ever get to a point with a customer where you're like, maybe the data is not the only thing that matters? Like, like, unpack this for you.
Yeah, I mean, I definitely think that's something I try to get across to a lot of people. It's like maybe the data is not the only thing that matters, and maybe you know the AI or data science or whatever you're trying to implement is not the only thing that matters, right? Like there's all this other stuff around it where I can I can churn out you 100 dashboards and whatever pretty rapidly, right? We can get a team, we can hire it that can build it, but what are you gonna do? That's always what I'm gonna ask. I'm always gonna be like, okay, let's say, you're asking me for this number. On the other side, what would you do if you had it? Right? Like if I gave you this number and it was high or it was low, would that change anything or is this just a curiosity? And there are things where like you have to give things to the board and you have to give numbers to the board, and that's one thing where it's like, make them happy, etc. But there are other numbers where it's like, okay, like who is this for? Like what is the plan? Because if your plan is to do nothing, I mean, just keep doing that, right? Like save yourself some money, save yourself a ton of time. Like there's all these companies spending tens, if not hundreds of millions of dollars, probably billions in some cases, trying to become data driven, and not getting anywhere, right? Like they're going through the motion.
Hyper focused on a metric. Like it's like they're not seeing around it. You're just so focused on metric optimization, and that's the only thing you're like looking at. And like depending on how you engineer the data, you can make the metrics move. Like that. So it's like, some part of it is like you get the data you engineer at the end of the day. But like, yeah, I'm always interested to see like how does when do they break out of the feedback loop? Like, yes, this is a signal, but it's like, we've got 15 other signals we could be looking at, and maybe some of those will give you better feedback at the end of the day. You brought up a good point though about like the numbers you need to report through the CFO and the board. And this is something Connor and I have been talking a lot about. And we kind of feel like they've got the data ownership wrong. Like Connor, you kind of talk about this, maybe tee it up for Ben.
Yeah. So, I mean, ultimately, the CFO is responsible for where the capital gets invested across the company, right? Or at least it gets reported into him. Yet the CFO never owns the budget, or we have seen very rare cases where the CFO really owns the budget around the chief data office or IT. And that's a structural problem. If the CFO were to own the investment in data, and then the office of the chief data office, or all of the investments happening across the tech stack, there might be different decisions made when you get sent off to go try and find a series of numbers that might not be in use. So, the question to you is like, where are you seeing? Do you think that's a paradigm that's realistic, where tech, IT is sitting, and then the data assets being created are sitting underneath the CFO versus, say, the CTO or CIO?
To frame it a little differently, it's like right now we see the CIO or the CTO tends to own the data asset that ultimately gets delivered back to the CFO. And it's like, why not? Why doesn't the CFO own that?
Yeah.
And literally have the teams under them.
Yeah.
If you're not producing results that meaningfully move metrics, then you're going to stop investing. It's like a clear feedback loop, a clear signal.
Or the CFO keeps getting numbers that are wrong. It's like, what the hell, guys? It's like, I've asked for this report 50 times. I'm still getting crap data.
Yeah. I will say not every data leader I've talked to dislikes reporting to the CFO, but a lot do. Mostly because obviously the CFO is going to be the one that's like, how do we do this for cheaper? And so then they're like, no, I want to be able to spend as much money as possible. Don't ask me to do this cheaper. So I do think there's always that pushback from a lot of people. I'm always curious, like, I think there's a lot of aspects of like, if you're talking about making data more operational, right? Because that's where I'd envision a lot of this goes, is like to operations, right? Like you're trying to make something about your operations better. So I can envision it going to like the COO. But it often, I think, either falls under CTO or CFO.
It's definitely both, right? Like the CFO, I mean, at the end of the day, CFO is trying to report back the company financials, give like either regulatory or business health. But you're right that the operations folks like that. But that's funny because operational data today is Excel. I mean, like that's what we see over and over and over again. And operations uses data. They just use their own version of it. They get their own slice of it.
I've definitely noticed that a lot of like the operations managers tend to be some like, I'm trying. There's this really good. He's got his book. His newsletter is called like the Operators Handbook. He's like really solid when it comes to like making it really dumb and like simple and easy to understand. Like just breaking it down so well. And I do think there's something to that. Like thinking more like an operator on the data team. Like there's obviously the financial aspect, but I think there's something where it's like you need to understand the business and how the business functions, which is probably most likely the operations side, in order to start making useful decisions. Because obviously you can see it from the financial side, and that side is like very numbers, and it's like, you're seeing everything in Excel from like spreadsheets. But there's like the real part of the business. It's like, how do we make this better? The more you understand that, that's where it's like, how does that data and what we're actually doing connect? How do we take this derivative of operations, and understand it so we can actually make good decisions? Because sometimes the data tells you things that are wrong, or at least accurate, but like kind of misleading. Like there's a whole classic story, I think, of Jeff Bezos talking about wait times for calls, and they're like, "Oh yeah, we got our wait times down to whatever it is." And he's like, "Okay, let's try it." And he like calls their whatever the line is, and it takes like 10 minutes for them to get a call, get like picked up from some customer success person. And he's like, "Well, I have the data right here. Like your average can be one thing, but I have the number right here, and this is the problem." So
That gets back to like data is just a signal.
yeah,
It's one thing you can optimize for, but there's going to be in the real world, just like your example, like just call the customer service line.
yeah,
Like this is the real world. Go out there and check. You don't have to just look at the numbers at the end of the day. I mean, our experience in operations has primarily been in like supply chain. That's where we've been doing a lot of work. I would say like it's really valuable. The most valuable use cases I've seen in operations were around inventory rebalancing and order intake optimization, like things where there is an actual answer that has immediate value, like cash value, like order intake optimization. Like how do I minimize fines? Like by filling these orders and optimizing for the constraints I have around the inventory levels and what plants could produce more of this thing, whatever.
yeah,
Those seem like really valuable use cases, and they're not. What's interesting about them is they're both a data problem because you need accurate information about like how many of the widgets are available in factory A, how many are available in factory B, how many could those factories make in the next 2 days. Like there's actual there's like the data quality issues matter because it's going to tell you, like, it's going to go into your plan and how you execute against it. But I think sometimes those have to do more with like the way those source numbers are collected. Like, okay, Bob is keying in the value every day, and like
yeah,
Bob forgets every day to key in, the end
yeah,
balance or whatever.
yeah,
Like, so like when you talk about these operational use cases, they tend to default to two things I see, like quality information about like stocks and like what's actually out there in the real world. And the other is like these decision trees and optimization problems that aren't data problems. That they won't give you the right answer if you don't put the right inputs in. There are all
yeah,
these optimization models, even pricing models that are going to drive your operational decisions, but it's like the old saying, garbage in, garbage out.
yeah.
And so like, what are your thoughts on like the operational data being tied to like not real time, but near real time information and how you solve that problem, which is a little different than the classic like ETL problem,
Sure. Yeah, I mean, like, definitely on the operations side, that's generally where real time tends to make more sense, right? Like, if the CFO asks you for real time dashboards, like, you're gonna close like once every month, right? Or something. Like, you don't need it. Maybe like once a week. I don't know. How often are you looking at these numbers? And when are you gonna make a $1 billion decision for where you should invest money? But yeah, on the operations side, generally, especially like you said, supply chain logistics,
Yeah.
that's where it often makes sense. Where it's like, yeah, we need real time. I think another thing I like that you brought up there is like you brought in that human aspect where it's like you kind of have to be on the floor to understand what's going on, right? Like again, these are
Exactly.
all the data is just derivatives of a very complex picture. And so I do think there's that aspect of if you're just making decisions purely off the data, it's like when you get a plan from an engineer and it's like, to build a house and it's like they put a screw behind some weird place that no human hand could actually reach. And you're like, yeah, functionally this works, but like I can't get there. And so it's like the same thing where it's like you hear sometimes like stories about like how Amazon treats certain drivers and how like they have these decisions come from on high that they're like, oh, you need to make this many routes, whatever. But it's all just based on data. It's not based on like are you actually driving these trucks? Do you have to like deal with whatever the everyday problems are to help make better decisions? Or are you just like abstracting that all away? It's like, no. The numbers is all I need to care about. Like, just fit the numbers. Um, so
The stories from Amazon sometimes in those top-down decisions are pretty horrific.
yeah,
Like,
yeah,
if anyone wants to go watch YouTube, like Amazon driver horror stories. I think a huge problem on the operational data side is some of the source systems though that they have to deal with. So warehouse management systems, transportation management systems, a lot of these are really old and they are essentially providing a incomplete, if not outright inaccurate picture. So if you're not talking to the floor operators or individuals who have to, and you're trying to then take the data out of those systems, join it with other systems, and then get some type of analytical view that's maybe not real time, but daily or weekly. It doesn't matter. You're going to be garbage out, garbage in, garbage out, like Dorian said, because those systems, they aren't either being updated by Bob, supposed to key things in, or they're not equipped to provide you the rigor of insight that you're looking for.
Hence why all data ends up in Excel, because the operators on the floor just stop using those systems and they go invent their own. That helps, that at least gets them to a point where they can sort of run the business on a day to day.
Yeah. They didn't get to design the systems. They didn't get to design the user interfaces they're dealing with, or the data, or how do they make it really easy for the guy on the floor, or the woman on the floor, to input the necessary information? It becomes very clunky, and
Nor do they want to do that, dude.
well, they want
They
to
don't
do it.
want to deal with that. They're like, they got a factory to run, man. It's all weird. Look.
Yeah, they're like, why do I got to spend this 5 minutes to put in these numbers? Like, that does not help me in my day to day. That just will give you numbers in the future to tell you to make me work faster.
So I don't even want to do it. I feel like that's the heart of the operations problem, is like passive data collection, and like how, if you could make the data collection automated and it was right, that actually helps the person who's now using Excel and kind of fingering the air, like trying to figure these things out. But I don't think people want to stop to like do data entry or check numbers and like, do reconciliation. I don't think they have time for that. Yeah.
No, probably not. Probably not.
But like, what do you think are the ways you could help there? Because like, to me, this is a really interesting problem space. People have been looking at AI here, especially too, like looking at unstructured data inputs, video feeds, pictures, monitoring location information, and letting AI try to extract inputs to the downstream pipelines. So like if you can, have a camera pointed at the factory line or input, inventory area, and they can like essentially count the number of widgets and then spit that back out into the sources. Like, what do you think about this idea around leveraging AI, especially for like, I mean, these approaches are kind of neural symbolic in that they're taking unstructured inputs and then they're feeding algorithms downstream. Like, what do you think the future of that is in this context?
Yeah, I mean, I think that's what, when I kind of reference, like, people, we now have more complex data that people want answers from. That's kind of how I view things continuing to go, is like the workflows themselves that this data represents generally, like, don't necessarily get more complex. They're kind of the same, right? To build that widget is very similar. But the amount of information we have on that workflow is what's constantly, I think, growing, right? Like I think about this first on the web, where it's like, well, we used to just know, like, hey, you clicked and bought something, great. Now it's like, well, we know what 5 sites you visited before this. We know like where on the screen you clicked. We know, like, we also know like everything about you. We know like where you live, etc., and like all this information. And so now we can paint a really good picture. And so I think the same thing's happening physically, where it's like, how, like, people want to get that really good picture of like, what is the exact problem, not what's like these general big trends, right? Like, people want to know, like, how do we know exactly what's wrong at this factory? Like, do we have that data that can get us and drill us into like the exact moment something went wrong? Can we see like the video feed when like a fire broke out and then prevent it from happening or something in the future? So that's what I see, and I imagine will continue to happen. Like, we're just going to keep adding more and more noise really in the data world, which is why I just envision data engineering becoming bigger and bigger, because it's like, yeah, AI might help, but we're just adding more stuff to it every day. People want more information, and they want more insights, and they want to be able to build better things from that. So
The sources could definitely expand, like if we think about like today, up until today, I think most of the data we process came from transactional systems. And that's one set of challenges. And now it's opening it up to the unstructured sources more and more, whether that's documents or video feeds or satellite imagery or whatever. We're expected to now process those. I think you're right. I think the surface area of the problem is going to grow in a massive form. I think that's why it's going to be important, though, to figure out not just like the technologies you use. I want to get to that in a second, just talking about the stacks you're using. But like, I think one of the more important things is, from like an operational context and a company structure standpoint, how do we get smart about the ways we leverage data? Because you can't boil the ocean. At a certain point, like, trying to process all of this data is a bigger business than the business you're currently in. Like, what?
Well, if you're Palantir, see Databricks, see you got Snowflake. Databricks just raised $100 billion.
Exactly. And this is like the space all the hyperscalers want to own too, with like Microsoft's Fabric and what they're trying to build. It's like, so at a certain point, you as an enterprise have to get smart about like, I guess, build versus buy decisions, but also like, what do we choose to process? Because if we choose to process it all, well, no one's ever going to use it all. It's like kind of like that analogy you were giving about the 80 columns in a table and people use 2,
Yeah.
like, why do I care about the other, 78 of these things? And
And the
it's the same
cost.
thing. Yeah.
Cost
So there's
of
massive cost to process all this.
And no one ever thinks this stuff is one expensive or that hard to do. But when you start to bring in huge amounts of data, structured, semi-structured, unstructured, and then trying to map it to a process, then map it to an outcome, everyone really wants a really quick win. But then they say, but yeah, give me all of my data, bring it in perfectly so it maps my understanding of the world and do it for nothing. So like there's a huge amount of trade-offs that need to be considered here, least of which is the what's driving that valuation of Databricks? The cost of using Databricks by customers.
The amount of data that flows through the place, right? The
Yeah.
data processing.
Great episode, right? Since you're here, you'll definitely want to check out FuturOps, a Palantir users conference coming to Dallas, Texas this October. It's 2 days jam-packed with keynote speakers, technical deep dives, tactical demos, and real-world use cases from Foundry's brightest minds. Whether you're a builder, operator, decision maker, or investor, this conference is for you. Scan the QR code to find out more.
How would you think about like this sort of way you're going to build your strategy around like the right way to think about the trade-off between deciding to process the data and use it versus just ignoring it, and finding other areas where you can, improve the business and figuring out like, where's the juice worth the squeeze, I guess. Like that's the methodology I want to understand.
Yeah. I think the one thing that most customers have some sort of core system that represents their actual business, especially if you're talking about like small businesses, you have one system that's probably your business, right? Like this is the majority of your business. You have a lot of other ones, like HubSpot and things around that sit around that, but there's like one that's like, this is your business. So that's generally always pulled in. And then the question just becomes, what are actual use cases that you're going to actually do, right? Don't just pull in data because it's like, oh, this could be interesting. It's like, yeah, interesting is great. But like, if it's just going to maybe save you $50 somewhere, it's probably not worth doing. So I think that's something is being very mindful on what you're doing and why. That's something I coach most data leaders. If I'm talking to them, like, look, just be willing to push back. People will always want to ask you for new things. They'll always want the new shiny thing. And if you I think I was talking to someone who was talking, like when she first became a data leader, she had this happen. It's like some other leaders will just ask to test you almost like in the sense, like they're like, will you say yes? Because if you say yes, I'm going to ask you every time. Right. So if you're not constantly like pushing back on certain things, you're just going to be asked to do everything. And so I think that's a big thing. It's like making sure you're very specific on what problems you want to solve and which ones are like not what you're going to do. Right. I think it's a big space. The more you do that, the more you're kind of focused on what data you pull in. Just always like when you are building things, build for change is another thing. It's like, look, you are going to bring in new data. You are likely going to change your ERP system in 2 years. Assume that and build this reliably, but also realize it'll probably change faster than you'd like. And so you're going to have to do some rework and improve it. And so I think those are things I take into consideration when I'm coaching or consulting with people, but also, I see a lot of when I talk to data leaders, that's things that they've all also said. So I'm like, oh, at least I'm in good company. So, yeah.
It's an interesting balance on the saying no thing, where I've seen chief data officers say no, but then once you've told them why, what the outcome you're trying to drive, they'll obviously acquiesce and be supportive. I've also seen many say, you're not touching our data. You're not going to do these things with this. And then if you do come up with a good idea that the business or operations wants to solve, then suddenly chief data officer says, well, now we own that initiative, that we're going to put our analysts and engineers. It's a very centralized approach. And then no one wants to talk to them because the business then ultimately doesn't get to own the solution. So there's a healthy balance there, I think.
There is for sure. I recently, I think, referenced something around pushing back and saying no on LinkedIn. And most people agreed, but there was like one person that was like, I think that sounds like you have a bad attitude, which I was like, okay, sure. Maybe. I don't think so. But No, there's definitely like nuance there. Like you can't just say no and be like your idea is bad, or you do need to. I think one example I often tell people is like you want to not be the boulder. You don't want to be the person that constantly blocks initiatives. You do want to be able to provide like solutions, alternatives, or just be honest and be like, hey, we just don't have the time right now. We'll have bandwidth later on. That's when we can take this project on. Or hey, this isn't in our current scope in terms of this team. What we could do is either, maybe work together on something and you could get some budget, I could get some budget, maybe we can build a new team, etc. Like there are other options. No doesn't have to be no forever. It just has to be like, look, our team is burnt out. Like there's no way I'm going to be able to do this. I'd love to, can't.
When you do say yes, I want to talk a little bit about like, what are the technologies that you're, heavily using? What's your stack look like today? Like, and what's getting you excited? Like, is there anything in the AI space where you're like, oh, this is actually helping us? I'm generally super skeptical of like AI coding assistants. I don't use any of the IDE versions, although we are building our own from scratch. Like, I do think AI, if customized and applied to your exact way of working, can be really, really useful. But I often feel like I have to constrain these things. Like AI is one of those things where like, if I don't constrain it to the maximum, I get like really bad output.
Yeah.
But anyway, what are the technologies you're using and your stack, and like, what do you think about AI coming into the data engineering world?
Yeah, I mean, I think there's some of the now standard tools. So, your Snowflakes, your Databricks, your BigQuery. I get to play with all of them. I mean, I have plenty of clients that have multiple of them on the same, or all three of them. So you get to play with all of them at some degree. I in terms of like data orchestration, data pipelines, we're still using one of the same tools that have been around for now a decade. So Airflow is still generally pretty popular. I do often wonder if that's just because I've written a decent amount about Airflow. So sometimes maybe I get a bias for clients that have it.
That's what coaching costs.
That's what I talk about. So of course people are going to come to me and about those problems. So there's plenty of that still around. I think that it's because it's open source. A lot of people like it. Obviously most people probably still don't know what it is, despite the whole now I'm forgetting, what is it? U2? No, what was the band and astronomer situation? Astronomer is the managed version.
Coldplay. It was
Coldplay, yeah. It's like, phew, that's a different thing. Yeah. So like that's Airflow's managed version essentially. So that was kind of like that's an interesting spotlight. First we get Luigi, now we get astronomer. Like, can we stop having data engineer things be in the spotlight for odd things? But yeah, so like Airflow is still pretty common. I sadly have not got to do much more than just play with Palantir when they gave me some demo. I think like 2 or 3 years ago at this point.
That was 2020.
But
Yep.
yeah, it was a while ago at this point. I think a lot of companies, you need more budget for that. Generally, I don't know if they've changed that. I know they were trying to forever ago.
They have a couple. Yeah, they have free dev tiers, and then a Palantir for Builders program, which is more like smaller companies or startups. You can get in now for a reasonable, still more expensive than others, but it's more reasonable.
They don't have transparent pricing though, which is, I think, a huge turnoff to a lot of developers and CIOs and people running the CDOs. Like, if you can't plan a roadmap on your spend, it's very difficult. And I think that's what drives a lot of the black box and vendor lock-in discussions. Is like, if you don't have transparent pricing, and I mean, they're transparent about the dimensions they charge in, but you literally don't have a published rate card, So without a published rate card, and you're going to go on there and plan, well, I'm going to process, 100 terabytes a month on this thing, what I'm basically going to just be subject to whatever they feel like my pricing should be. Like, that's a really scary thing to invest.
Yeah, I don't want to. I'm going to pay $1 million next month, and I'm a small company where that's our entire income, net income. Like I can't do that. We're out of business. So yeah, I think that's one of the things that I often run into. Like when it comes down to it, is like, say what you want about some people feel like Snowflake is expensive. It is currently for me the easiest to explain in terms of cost. It's like, look, if you have an extra small Snowflake instance and you run it for 24 hours in a day, it'll cost you $72. That's the end. There's nothing more. Obviously, if you go up in scale, it gets more. But like for a lot of people, that's like they don't even need that. I have clients who are like running it for like an hour a day, and it's like, yeah, okay, you're spending $3 a day. So by the end of the month, you'll spend, about $100. Cool. Like,
Yep.
now you know. And if it is $1,000, at least you know why. But I think some of the other solutions make it a little harder. They have like so many different pricing tiers. BigQuery is kind of in this like, we'll tell you after you run this query, or we'll try to estimate it before you run it, and then we'll tell you how much it costs. And it's like,
Right.
okay, how do I kind of have to know a lot more about BigQuery to figure out pricing there. It's not impossible, but it's a lot. There is something to be said about like making it easy to explain to people. I think is important, especially again if you're reporting to the CFO, who's going to be like, why are costs of 1 month 3 times what they are another month?
Yeah, the Databricks has very transparent pricing too.
Yeah. I think their next big fix is they just need to like simplify like the types of offerings. I know like now they've like pretty much tried to like move
Serverless
you to,
version now.
yeah, they tried to move you to serverless, but it's like because you still have the options of the old ones, I think that can still make it heavier.
I understand the move to serverless personally if you're doing a lot of active engineering. This is both in the context of data engineering and anything else.
Yeah.
I've essentially moved everything back to container workloads that was once serverless on the application layer, not data engineering layer, but the application layer, because serverless tends to be more expensive at scale. And
Yeah.
it's also a shit feedback loop when you go to deploy.
Yeah.
And that feedback loop is more expensive than whatever I was spending. So like if I calculate the seconds that an engineer is wasting waiting to deploy and test their pipelines versus something that has a warm environment that's ready to go, and I add up all those seconds, like I tend to get to a bigger number than whatever the compute savings was.
Yeah.
And so I tend to be skeptical of serverless as a thing, but on paper, it definitely looks cheaper. I'd be curious to get your thoughts on like, are you excited about the serverless offering from Databricks? And like, are you generally just pure container-based workloads and trying to optimize for warm environments? Like, what's your approach there?
Yeah, I think you kind of covered a good point there, where it's like it really is dependent on like, look, if you are just going to use this occasionally, it's honestly great, right? Like you're going to spend less money. If you are a heavy dev shop or you're planning to be real time all the time, it's going to be more expensive, more than likely, right? Like it's like trying to run lambdas and you run millions a day. Yeah, that's going to be way more expensive than if you just had something else considerably simpler, just a server handling all your requests, in your underneath your desk or something. So no, I mean there are benefits, but you do have to be very mindful of those benefits.
I heard you talk about a long time ago, like how when you're doing data engineering, you actually get to a point where there's a feedback loop from the application layer. So it's like, we make all these data products, they consume them, either through APIs that developers are accessing or, there's dashboards or whatever. And then we get feedback from the team and then that feeds like changes in the pipelines. And then we start getting this like feedback loop going where the business is improving, through actual, combination of the work the data engineers are doing, the application engineers are doing, and then the business users or whoever's driving it. Good example of that too is like e-commerce sites who are driving engagement based on A/B tests that they're running, and a huge part of the models they're building are fed by the data engineering team is building. And now in real time, you can drive engagement and get to better numbers, because of the modeling that took place that can now be used in these real time use cases. But like the interesting thing about Palantir is that it sort of tries to bridge the gap under a single platform for like the application layer. And like, so most of the time when a data engineering team is done, the definition of done is like, the data is sitting in S3, like some object store that's been processed. It's sitting in a columnar database of some kind, or is also processed back out to like something backing the API layer. It could be Spanner, it could be, an RDS system, it could be MongoDB, who knows, but there's some application layer database that's being used. It's consuming that data as well in one form or another. The interesting thing about Palantir is they have the ontology. So they kind of land all of that, like the application layer, into the ontology store, and they have their own, data set thing. But like, what are your thoughts on tightening the feedback loop as an endeavor? So it's not like what makes a great data engineering stack and sort of a great outcome is how tight it is tied to the feedback loop of the consumers. And a large part of that is the application layer. So I'm like wondering, what are your thoughts on like how companies are ultimately consuming this data, how apps have to be built around it? And then like, what does that feedback loop that ultimately feeds back into the data engineering landscape look like? And could you possibly see like how the differential pricing around Palantir, part of that is at least maybe driven by the fact they have the ontology and sort of north of the ontology layers in there?
Yeah. I think this is kind of where a lot of companies want to go, right? Like this is what you're seeing kind of almost with like the recent purchase from Snowflake and Databricks, and they're buying out transactional systems. And Snowflake was trying to do this back like 2022. They had like hybrid tables where it's like, can we, obviously slightly different than an ontology, but can we essentially join your transactions, the actual applications that people are using, to these and the analytical side, and like, one, make it easier just to work with that. And then I think this extra thing that you're also referencing, especially with Palantir, is the fact that you can then build like specific data products that then go out and service, and then maybe create more data, and then et cetera. So that's less, I think, touched upon by a lot of these other solutions, but something that Palantir's been pushing for. I think it's a good goal. My guess is there's human challenges that have kept us from getting there. Like there's more people things than there are maybe technology, and maybe we finally fix it. Cause thinking about like SAP, right? Like SAP originally is like a lot of like, ERP type planning your business system. And then they added all this other stuff where they're like, oh, you can do business objects and like all this reporting on top of what we have already built. Obviously the benefit of Palantir is I think it's a little more custom. SAP was obviously very rigid back in the day. But that was a goal, right? Like I think that was a goal that they never got to. And now the people who are still on SAP are there because switching would be too expensive, and so SAP will exist forever. But yeah, I mean, I think it's good. I don't know how we get there because it feels like there's some human wall that we keep hitting where it's like it should work, right? Like we should be able to just like bridge this gap between the more real operations and getting data into analytics. Like we spend so much money just getting data from transactional systems to analytical ones. So if we could bridge that gap and just cut it out, that would save us billions and billions and millions of dollars, and would take out a lot of companies.
Both Snowflake and Databricks made huge investments in that. Like Databricks, I actually feel the Databricks version of the transactional system is more flushed out right now, in my opinion. And they do have like a Node SDK for working directly with it, though from my analysis, it didn't support connection pooling, so I don't know how useful this thing is going to be. Like, because as soon as you start talking transactional systems, the bottleneck for your applications now become the connections to the database and the load on that transactional system and how much it can support almost universally. Like that becomes the thing where a lot of development effort and time is put. So like, it feels like a large endeavor. Like I would say part of the reason that you're seeing this, like, why is it so hard to go from one to the other, is that they're just optimized for different things. Like at the application backing layer where you have like microservices built across, especially if the microservices under heavy usage, a lot of time you're looking for scalability, like horizontal scalability in that system and the ability to manage large amounts of concurrent connections. And you need like low latency read write, and it's just like massive challenges. And like, I think Google and they have like Spanner, which I think is one of the premier RDS systems for scaling horizontally like this. MongoDB famously advertised a lot of horizontal scalability, though it's actually really difficult to.
I'm hearing so much frustration from MongoDB people, but they did really well recently. So if you had MongoDB stock, congrats.
Yeah, they crushed it. I saw that yesterday. As a developer, I've actually been a huge advocate for MongoDB because I felt it was the best general purpose document database out there. But it is famously hard to manage the sharding and scale that thing horizontally. And when you manage your clusters, it's I would always do it through Atlas, which I believe is their like paid service offering,
which is the thing that made so much money.
Exactly, because like if you try to do this yourself, good luck. Trying to scale the cluster and have no downtime is ridiculously hard on your own. And so, at least from my opinion, like at my level of engineering prowess or whatever, I would say it's ridiculous.
Yeah, you're gonna get someone in your comments be like, "It's so easy." Actually, all you have to do is
always, yeah.
You're just a skill issue.
Exactly, skill issue. It's a me problem. I accept that, But like, but I think part of the reason this is so hard is just because they're optimizing for different things and trying to build this all together. What ends up happening, in my opinion, is like the integration points are where all the challenges are. It's like all that stitching together, all of the distributed system problems that can arise as you now try to sync these two things together and then manage a consistent deployment and observability and monitoring system across it all. That is like, now, again, we're back to that conversation about like, well, there are companies that do this for a living, like at a certain point, if you're a company trying to reinvent that and amortize the cost over a customer base of one, you're engaged in the worst investment possible, because it's not the business you're in. It's like relatively an unsolvable problem unless your name is Netflix or Facebook or whatever. because you don't have the engineering talent to ultimately do that. So I think it's like that is probably a large part of the pushback. And again, it's just in that evolution of software systems. The more complicated we make them, the more they push back on us and give us feedback that isn't good. It's just like there's too much to manage here. But I do think it's interesting that Databricks and Snowflake are trying to bridge this gap. Microsoft is also endeavoring here with like Fabric and some of the work they're trying to do to kind of combine that with their low code and no code offerings. Do you think at a certain point the enterprises just say we're done with trying to build our own solutions, to say it's better to adopt anything rather than trying to continue down this road of like bridging the gap?
Great episode, right? Since you're here, you'll definitely want to check out FuturOps, a Palantir users conference coming to Dallas, Texas this October. It's 2 days jam-packed with keynote speakers, technical deep dives, tactical demos, and real-world use cases from Foundry's brightest minds. Whether you're a builder, operator, decision maker, or investor, this conference is for you. Scan the QR code to find out more.
I remember listening to an interview. I don't remember who the CEO was, but they were talking about they were referencing Salesforce, and they're like, yeah, Salesforce is a great product. They got us to where we are, but now we need to build our own version to get a competitive advantage. And so I do think there's often this notion that it's like somehow we have to constantly build our own thing because we need the competitive advantage. So I think there's going to always just be that thing where it's like a new CEO is going to come in. They're going to be like, let's build our own. It's just this kind of forever cycle, right? Everyone always hopes that they can do it. I always hear this line from every so often in projects where it's like, someone will be like, I don't understand why we can't do this. At the last company I worked at, we had this. And I was like, okay, well, that last company, did you also have like 30 or 50 or 100 or 1,000 engineers? Like, you have one here or you have 5 here. So let's, they're busy. So yeah, of course you don't have everything, or you're 2 years old. That company was 30 years old. Of course they had more stuff. There's always somewhere someone else has done something better. So everyone always remembers that. And they're like, no, we can do it. I remember seeing it, but they don't know all the work that maybe it was required to get there.
Well, if I put this under like a bucket of the Dorian's favorite word, transformation or digital transformation, where you're trying to bring this stuff together.
I can hear the dump trucks backing up to the dumpster fire with all the money in them. Just dumping them in.
But God, if you just looked at like even the companies that sell the strategy around digital transformation, if you look at their reporting or their thought leadership around this, BCG as an example, they report out that 35% of companies that go on these transformation journeys to stitch together systems, get an analytical layer, real time or otherwise, operational capability, 35% outright fail, another 35% have middling results, and then like 30% actually accomplish anything. Forbes reports something like 80% failure rate. So it's something between 70 and 80% that when companies try to go it alone, or the new CEO walks in and says, okay, we're going to get a competitive advantage with technology, basically 4 to 5 times they're going to fall short. Or
I think that number is way higher, by the way. Like I have no data to back this up, but anecdotally, what I see is like those studies will look at a point in time and measure success. If you go back and look 3 years later, is that system still in use? Almost universally, it's like, no, it's been trashed, and we built it again.
That's what keeps this forever. We were joking, or I don't know who asked me this. They're like, so as part of your consulting business, do you just like find certain leaders and like follow them around and wait like a year or two after they like start and then leave at a company and like, hey, do you need to get things fixed?
well, like, okay, so you implement a solution. Let's say you're not even very good at engineering at all. So you deliver a moderately successful, but maybe poorly engineered solution. And then you just stay around the hoop until that thing kind of falls apart because you didn't address the structural issues, the change management, the organizational operating model, all the things that would make it scale and be successful for longer. And then you get the phone call 2 years later saying, hey, we want to rip that thing out. You guys know how you built it the first time. We've picked another vendor, another operating system or technology platform. And you're like, yeah, we're experts in that too, which they're not, but then they're willing to just sell the next one, the next one, the next one. It's crazy.
I think the structural issues are the biggest root cause. Like for me personally, working at startups, what I've seen work is like decentralization as the model to success. And you build small mission-driven teams that are ultimately responsible for an outcome, and they have to maintain that outcome. Anytime you centralize this stuff under a CDO or some office, and basically all outcomes now are owned by that thing, it's like no outcome is owned by that.
Sounding very Elon Musk there. Wasn't that something he said somewhere? Like you can't It was something like
Yeah.
something like you should never have like any outcome basically owned by like again some entity or some team. It needs to be owned by like basically a person. Otherwise, yeah, it's just like, oh yeah, that team deals with it, and then no one really has to take responsibility for it because then you know, oh well, now there's new people on that team, so you can't blame them. They're new, so you're never gonna.
I think that's the number one fix these companies could make is take a decentralized approach that big tech does, and it actually works, and you can measure the team performance, and then you align, on the company mission through things like OKRs.
That would be
seriously aligned.
That would be so hard.
Oh, that's our mission, but it's hard, dude. Because like I actually think that's the biggest impediment to enterprises actually driving GDP is like you need to learn how to use technology. But in order to use technology, you got to learn to destructure these things and decentralize and operate differently. Yeah, it's like that's the battle.
You can offer some sort of deconstruction service in reference. I don't know, deconstruct restaurants or something. I don't know.
The hard part is that again, the organization pushes back. It's like there's this organizational gravity. It's like a giant black hole gravity well. And it's just like we're gonna go back to doing things the way we did them because like that's how we work.
That's how we work. And then that company gets bought out or that company gets sliced up, and now you've got 8 different companies you got to deal with, and yeah.
Today we covered data engineering, large scale in nature and otherwise, the successes, the pitfalls, the reasons behind digital transformation failures, and how you can potentially operate differently to succeed, structural differences between big tech and traditional enterprises, and some fun stories from our collective experiences. Ben, where can people find and engage you?
Yeah, you can probably just look me up under Scale Data Guy on YouTube, LinkedIn, Substack, and you'll find some bit of me there. Or you can just Google me and probably find me there as well.